Hi everyone there. Welcome to the lecture 3 of engineering drawing course. In this lecture we will study uh, concepts of lettering and dimensioning used in engineering drawing. Now coming to lettering and dimensioning in engineering drawing. This lettering can be of two types. One is single stroke, other is Gothic. Only difference between them is here letters are used as thin with letters are formed using thin lines like A, D, C, etc. In Gothic, we use thick lines to draw this or to represent these letters like this. These are thick, this is thin. That is the difference. Further, from single stroke, we have two things. One is vertical type, other is italic. Difference is a vertical lettering will be like A, B, C, D, so on. For italic, we have A, B, C, D like this. We observe with horizontal, this edge makes around 75 degrees approximately. Now, that is one part in single stroke Gothic. When I say single stroke, you might be thinking that I should not lift my pen or pencil, whatever it is, when I'm writing these letters. No, that is wrong. We can lift it. But for appearance wise, the letters will be as such as if when I start writing a letter, I don't come back and go again. In a single stroke, I'm completing it. Every line or every element of that particular letter. It is not like if I'm doing like this and again going back and again doing like this and again doing like this. That will become thick, going to and fro. I mean, so this is single stroke. This again will become Gothic. That is the difference. So say that is what I meant to say. So in A, when I write A, I'm lifting my pen to draw this horizontal line within this shape. So still it is a single stroke. So what I meant to say is, the single stroke doesn't mean that the total letter I am writing without lifting the pen. It means that for appearance purpose, this letter is as if I did it nowhere I have repeated this drawing this line to and fro wise. So that's what it meant. Anyway, that is as far as lettering is concerned. Now, a little bit of important points you need to remember, but you may not follow it very strictly at undergraduation level, but it is good if you remember them. Say for headings, height of the lettering that needs to be used is 6 mm to 8 mm. Now for subheadings, it will be somewhere between 3 mm to 6 mm. By the height, I meant to say, for example, say this is A, then this particular length, this particular altitude is the height. That should be 6 to 8 mm for headings. That same thing, height should be 3 to 6 mm for subheadings. For notes or dimensions, it should be somewhere between 3 mm to 5 mm. So it is good if you follow, that is not a problem. And you should keep in mind that whenever you're writing something in the chart, it should be very clear and legible. One more thing is height to width ratio. That is 5 is to 6, I guess. It is something like that. But anyway, it's not very important to follow it very strictly when we are writing the things with hand. In computer anyway that is possible. With hand every time it will, if you do that, it will take a lot of time. So what the purpose of the rule is to have a proper and legible writing. Say I want to write B, C, D, then proportionate to height, I should have some width so that it is clear, and there should be certain gap between that. If I do like this, do you think it is clear? It is very clumsy. So there has to be certain gap. There has to be certain width. There has to be proportionate height. So you have to understand how to write the things. So it should be neat and clean, and it should be in a legible manner. That means anyone should be able to understand what we have written. So that is the requirement. Now, one more thing is, it's a drawing number. Drawing number. Its height should be 10 to 12 mm. So in a drawing chart, you will have a title block here. In that title block, you will have a drawing number. The drawing number should be of this height. Your name, that firm name, those all things should be of this. If it is a subheading, it should be of this height. So just for purpose, I have mentioned. That is all about lettering. Now quickly going through dimensioning as well. So purpose of dimensioning is to represent an exact length of a feature. Exact length of a feature in a given engineering drawing. Or some represent what that feature is all about. Let's say it is a hole, so it is some machining or whatever it is, some kind of special feature, whatever it is, we use it, you represent it using this dimensioning, mainly for geometrical features. Now, how there are certain rules and there are certain types and classifications for dimensioning. In dimensioning, there can be two things again. One is functional dimensioning, another one is locational or datum dimensions. Functional one means, say for example, there is a shank in a thread. So thread is not, say for example, is the screw, as it is a bolt with a bolt head and so on. Entire thing will not be threaded. It will be threaded up to, generally it will be threaded at a certain extent, say up to this length. So this length, we call it a functional one, and whatever dimension we give it, these are functional ones. Anyway, at the same time, I am telling this as well. This part up to here threading is done. So this part, this dimension is called functional dimension. I mean that particular dimension which is representing the functioning part of the body or functioning part of the diagram. Now anyway, when I have drawn this, I will explain this as well. In bolt, like objects, that means in the diagrams where external threading, bolt is externally threaded, nuts are internally threaded by using tapping. So this is a bolt, so externally threaded element. Externally threading will be represented like this, and nominal diameter will be the outside diameter. External outside edge to outside edge. This is actually circular part. When we look like this, it will be circular part. This outer edge is representing this one. This inner thing is representing this part. So you have to visualize a bolt. So this outer edge to edge diameter, this is M20. That means in metric system it is 20 mm diameter. It represents diameter. When I say M20, automatically it is representing certain diameter of some threaded part. That is this. This is simply 20 mm. That is length of the threaded part is 20 mm. That is how our bolts or externally threaded elements we give dimensioning. Now that's okay. Again in dimensioning, there can be two types, classifications. One is aligned system and another is unidirectional system. In aligned system, say for example, this is my object. When I from bottom to up for this, and here So for horizontal dimensioning from left to right, for vertical ones from bottom to up in inside one in this area. Say it is 50 mm. So this is 70 mm. Observe here, this particular one is not cutting the dimension line, it is off the dimension line, it is apart, away from the dimension line. Here also it is on the above the dimension line but not on the dimension, it is not touching the dimension line, it should not touch. So such system we call as alignment system, aligned system. Whereas in this case for the same object, we can have dimension something like this as well. We can write it as 70 mm. When we are breaking the dimension line and in between we are writing what is the dimension, then such system is called unidirectional system. So this is used for dimensioning of huge or large parts like automobile or aerospace components. Now there is again another system, another classification based on how you provide dimensioning. There is continuous or chain system, and another is progressive or parallel system. Say for suppose something like this. Same one I am drawing here as well. Now we can have dimensioning like this. This is 20 mm. I am not writing all dimensions are in mm if I write in chart paper. When I write in the title box or somewhere above on the right top corner that all dimensions are in mm, then I need not write mm every time. Simply if I write number it is fine. 20, 20. This part is 30. This part is 40. And this total part is 100. Automatically it says it is giving indirect. You are might be saying I am not giving dimension for this, but yes, I have given it indirectly. This is 20, this is the total 50, and here 40, total is 90. And this one total is 100. In between 10 is missing, that's why. 10 plus 40 plus 30 plus 20 will give a total 100. So indirectly we have given 10. Again, if you write 10, or in spite of giving 100 here, that means it will become redundant dimensioning system, which we should not, we should avoid. So this one is there. This is continuous. See, total dimensioning I have given 100, it is okay. But the other ones, these dimension lines I am representing, all will be collinear, chain in a line. So that we will call continuous chain or chain system. Another type is I will draw an extension line here. I will draw extension lines like this. Now, this is 20. From the same extension line, I will draw this line as well. 20 plus 30, that I will directly write it here as 50. Now again from the same dimension line, I will write it as 50 plus 10, that is 60. From that same dimension line again, I can write it as total thing is 100. There is no space actually. So 100. So from the same extension line, you are drawing all the dimensions with the drawing extension line from respective element. In this, observe this part I didn't mention. Actually, it is 40. How we get it? Total is 100. In that total is 100 up to here it is 60. Out of 100, when we deduct 60, remaining is 40. That's how we can find. Anyway, it is not to scale. It is not. It is actually 10, but I have drawn it as a bit more one. Anyway, don't worry about that. Understand, from the same extension line, we are drawing all the dimension lines. The different respective feature, geometric feature. This is a step 1, step 2, step 3. So that is respective geometries, geometrical features. From that I have drawn extension lines, and to that I have drawn dimension lines. So this type is called progressive or parallel, and we don't have any confusions in this, and it is very neat and clean compared to this. Sometimes this is a small diagram, but in a complex diagram this can become a bit clumsy and confusing for us. So generally this is preferred. Now coming to the next one more thing I wanted to say, that dimension lines should never ever cross each other. Dimension lines should not cross each other. But extension lines can cross each other if required. Say for suppose there is certain drawing like this. Now I have a length of say 20 mm here. This is a circular element, actually cylindrical, with steps, step 1, step 2, step 3. This is front view, sectional view. Now if I see its side view, it will be something like this in steps. So anyway, that we will learn those are in the later part of this course. But now say it is 530. This is 550. Now observe here, this is an extension line for dimension 50, and this is an extension line for dimension 20 mm. Now they are crossing each other. It is not a mistake. It is okay. The extension lines can cross each other when required, as and when necessary. Because if you draw it from here, in this diagram it is okay because it's very simple. But in complex diagrams, if you draw the extension line too much away from the feature, then you may get confused. So it is generally followed rule that extension line is some 3 to 4 mm, maximum 3 to 4 mm away from the actual feature edge from which we are trying to measure. So they can cross each other, that is not a problem. But dimensions should not cross each other, right? So also, one more thing, to have a simplicity and clarity, smaller dimensions are written first and bigger dimensions are written later, away from the actual feature. We will extend the extensions and extending extension lines accordingly, and then we will place the dimension there. Okay, hope you have understood this dimensioning features. So with this, we end this concept of lettering and dimensioning. We shall meet in the next class for discussing the next topic. Thank you.